All right, guys, in this video, we're going to talk about square roots and perfect squares. Has anyone ever seen this type of symbol before, like that? Well, that is a square root symbol, or we actually call it a radicand. A perfect square is something that is multiplied by itself. So like any number that we get when we multiply a number by itself, like 4 times 4 equals 16. Well, 16 is a perfect square. So we're going to look at those today. So let's look at perfect squares. We're just going to write them like this. 1, that is a perfect square. What do we multiply by itself to get 1? Well, 1. So 1 squared equals 1. 1 is a perfect square. 4 is our next one. 4 equals 2 squared. 9 is our next one. That's 3 squared. 16, that's a perfect square. 4 squared. 25, 5 squared. Do you know the next one? 36, 6 squared. How about the next one? 49, that's 7 squared. 64 is 8 squared. 81 is 9 squared. We're going to go all the way up to 15 squared. Okay, so do you know the next one? That would be 100. 10 squared. All right, let's see here. What would be 11 squared? 121. And 13 squared is 169. And 14 squared is 196. Just switch those numbers around. And then 15 squared is 225. Okay, so it's helpful to look at it kind of in this direction so that you can see the relationship between the number we square and the number that is the perfect square itself. The perfect squares, just to remind you, are these numbers right here, okay? They're these numbers, okay? Perfect squares, these numbers, okay? These numbers, thing that we got by multiplying a number by itself. All right. So let's do a little exercise. I'm going to ask you for or about square roots. So I'm going to scroll down a little bit, maybe zoom out a little. Okay, so in our first question, we've got the square root. Now, what on earth does that mean, square root? Well, squared, like this little symbol here, and square root are opposites of each other. Okay, so if I write this, I can also write it like this, right? Correct? Because remember that 8 squared is the same as 64. And since I just said that the square root is opposite of squared, that means that these things cancel each other out. So the square root symbol and the squared can cancel each other out. And essentially we get just 8. Okay, so let's try another one. 16 squared. Well, what does that equal? That's the same as 4 squared. Now you can look at your chart if you ever forget what the square root of 16 is, or what squared equals 16. But we just cancel out the radicand, the square root symbol, and the squared, and we're just left with what's inside, which is 4. Okay, I guess I can keep the same color here. Let's try 36 squared. You try this one here. Okay, assuming you've tried it. That's 6 squared, which equals 6. Square root of 6 squared is 6. Number 4, how about the square root of 81? What is that? Let's look at our chart. Well, 81 is 9 squared, so that's the square root of 9 squared, which is just 9. Okay, so just remembering that the square root and squared symbol, when they're both together like that, they cancel each other out, and then you're just left with the number that was squared. Okay, now we're going to be doing in this next part of the video, we're going to be doing a little bit of fancy footwork. Okay, so let me put a line right here. This is part 2. And in this one, we're going to be taking square roots of numbers that are not perfect squares. Like if I asked you, find the square root of 45, how would you do that? Well, you're probably thinking like, well, if I'm looking back up at my chart here, 45, I don't see that on here. I don't see 45. It's not a perfect square. And you're correct, it's not. However, this is where we have to start thinking about factors, okay? What factors of 45 are perfect squares? Let me ask that again. What factors of 45 are perfect squares? And when I say factors, you should know what I mean by now. Okay, I've been saying this word many times, said it hundreds of times over the course of this year, but it's two numbers you multiply together to get something. So what two numbers that multiply together to get 45 do we have where one is a perfect square? Well, let's look through. Okay, so 45, what are the factors of 45? We got 1 and 45, right? We got 3 and 15. We have 5 and 9. Hey, there's a perfect square right there. Okay, so what I'm going to do is I'm going to rewrite this as, and this little dot right here, it actually doesn't mean anything. So I'm going to get rid of it. So we rewrite this as 5 times 9. Okay, fair. Okay, now here is a property of square roots. Square roots are cool, okay? Because you can do this. This is called the product property of square roots. Are you ready for this? Watch. I can rewrite this thing like this with two square root symbols like this, okay? So it just split into two square roots. It's kind of like it just divided like a cell or something like that. But square roots have that property, meaning they are able to do that. So now things become a little bit easier now, don't they? Okay, because square root of 9, what was that? That would be 3, right? So I'll just rewrite the square root of 5 times the square root of 3 squared, which is the same as the square root of 5 times 3. Okay, and when we have something like this, we cannot simplify it anymore, really. Okay, we're just gonna, the correct format, we're just gonna write this 3 in front of the 5 like this. Kind of like the 5 is a variable, okay? It's almost like 3x. Well, now it's a 3 root 5. Instead of like three x's, now we have 3 root 5s. And this right here is actually that is an exact answer, okay? Okay, this is the kind of answer I need from you, is an exact answer. What would be an example of an inexact answer? Is if I took this, I just went to my calculator, I punched in 45 and hit the square root symbol. Then I would get a decimal, okay? What would I get? I would get like, I don't know, like, what would I get? I would get some number, but it would not be an exact answer because it would be a repeating decimal and it would go on forever, and I will not accept answers like that. I need your answer as an exact answer, and your exact answers look like this, okay? All right, I think I've been clear about that. Number two, we're going to take the square root of 75. Oops, that is not a 7. All right. So what perfect square is in 75? Well, you would know that it is 25. 25 times 3. And then because of this interesting multiplicative property of square roots, we can write it like this. And then remember that 25, why did I choose 25? Well, because 25 is a perfect square. Look up at our chart right here. See, 25 is a perfect square. So now I can just rewrite that as 5 squared, or the square root of 5 squared, times 3 equals 5 times the square root of 3. And we're done. That's it. That's your answer. That's how your answer should look. All right, how about number 3? I'm going to switch colors because I'm tired of black. All right, number 3. How about the square root of 8? A little bit smaller, more manageable of a number. So 8, is it a perfect square? No, it's not. So we're going to have to find a factor of 8 that is a perfect square. And I see it right there, 4. So we're going to rewrite this as 2 times 4. So I'm going to rewrite it as this. 4 times 2. You'll see why in just a sec. And then how can I split? Well, I can rewrite it with 2 radical signs now. And now I rewrite the square root of 4 as the square root of 2 squared equals 2 root 2. See, the reason I put the 4 in front of the 2 is just so that it was consistent and I could rewrite that right there. Okay, so that became that, and then the square root of 2 went down right there. Okay. Number 3. Number 4 now. Square root of 50. Okay, now what within 50 has a perfect square? Think. Look at your chart. Look at all these highlighted perfect squares right here. Do you see any factors of 50? I see one right here. Again, 25. Okay, so I'm going to rewrite this as 25 times 2. The square root of 25 times 2 equals 2 square root symbols now. 25, the square root of 25 times the square root of 2. Do you remember how to do this? The square root of 25 is what? 5. Okay. Equals 5 root 2. And we're done. Hopefully this is making sense now. That is squares and square roots. Perfect squares and square roots.